In this problem, we're given a set of ordered pairs, x values and y values, in a table below. And I'm going to focus on part B, using the TI84 to find the regression equation. I'm doing this problem for both college algebra and statistics. In statistics, we'll take the problem a bit further and find R, the measure of linearity. So the first thing you want to do is get the raw data into the calculator, and you're going to do that from your stat menu. Okay, so you want to press on your stat key, and your first choice is edit, so you can click enter. Now I already have some data in my calculator, so I'm going to go back and clear that. If you don't have any data in your lists, then you're good to go. So I'm going to arrow down to choice 4, or I could just type in 4, which is clear list, and I'm going to tell the calculator what list I want to clear. So that would be list 1. Your lists are right above your numbers, so that would be a second 1, and then enter. And then I'm going to go back to my stat menu and enter in the first list, or the first column, all of the x values, and then do the same thing for all of the y values in list 2. Now it's important to enter in the data in the same order. These are ordered pairs, so the order that you enter in the x values, you have to enter in the same order for the y values. Okay, so after I hit each entry, I hit enter. Okay, and then going over to list 2, arrowing over to list 2, pardon me, I will enter in all of those y values in the same order that I entered in the x values. Whoops, I made a typo. It's very important to enter in the data correctly. Otherwise, your linear regression equation will not be correct. Okay, so now that I have the raw data entered into the calculator, I'm going to go back to my stat menu, which is my STAT key, and I'm going to right arrow over to calc, and you'll notice that choice 4 is linear regression, and in parentheses you have the standard form for a line, ax plus b, a being the slope of the line and b being the y-intercept, the y-coordinate of the y-intercept. Okay, so I'm going to choose 4, and I need to tell it what is my input list and what is my output list. My input values were put in list 1, those are my x values, and my output list was list 2, the corresponding y values. So I'm going to go second 1, okay, list 1, and then I need to separate it with a comma, and then list 2. Okay, and then I'm going to hit enter. Okay, so the calculator has given me that regression equation. Okay, so if you wanted to round to the nearest hundredths, your equation would be y is equal to 2.04x plus 0.71. Now in statistics, you're also asked to find R, the correlation coefficient. How strong of a linear fit do we have? So to get your calculator to display this, you have to change your diagnostic, and to do that you're going to go second 0, which is second catalog, and then you need to arrow down till you find diagnostic on. Now you only need to do this one time unless you reset the memory in your calculator. Okay, so keep scrolling until you find diagnostic on. Now, college algebra folks aren't required to find the measure of linearity, so if you're in college algebra, you could just turn this off now if you want. Okay, almost there. Okay, so I am down to diagnostic on, and I'm going to press enter. and then enter again and it'll say done. Okay, so I'm going to go back to my stat menu and right arrow over to calc and choose 4, and I'm going to go through the process again. I'm going to tell it what my input list is, comma, my output list, and enter. Okay, so we have the same pieces as we had before. We have the slope and the y-coordinate of the y-intercept, but also we have r squared and r. That last value, r, is what you will need for statistics. R squared is the amount of variation that is explained by the model. So you can see that there is a very strong linear relationship, and you can compare that to your critical values in the Pearson correlation table.